All right. Happy to see everyone, and I'm really happy to be at this stage, and we are proud to sponsor this event with Subsquid. And today I'm going to talk about the future of indexing with Subsquid. So the goal of this talk is twofold. So the first is to show and present what we already can do with Subsquid, and even more that can be released around Polkadot Decoded at the end of June, and have a glimpse into the future of Web3 and the dApps that are gonna power the next bull run, I guess, which is probably going to be quite different from what we currently see. Okay. So before we proceed, let's pick into an architecture of a modern dApp. So usually you don't connect your dApp directly into the blockchain node, and usually there is a data middleware where there is actually an API that your dApp is speaking to, and there is a blockchain node and something in between that is usually called indexing middleware. So why is it important to have a middleware in between? Why it's not like a good design to have direct connection to the blockchain node? Well, because there are two axes. The first 10x is it gives you 10x better UX. Because if you have an API, it allows you to cache the content so that your pages have instant loading time. You can have very rich UIs on your dApp, and you can actually scale your dApps if you anticipate that there are going to be thousands or even like millions of users. If you want to do this kind of stuff with just direct blockchain connection, then you are going to hit the limitations of the infrastructure. And scaling blockchain nodes is a lot more difficult compared to scaling usual APIs like REST or GraphQL APIs. And another reason to have an indexing middleware that isolates the blockchain logic from the front-end logic is that it actually gives you 10x better development experience. Because basically your front-end devs may have next to zero knowledge about the blockchain specifics and develop the website or mobile app as if they're building just a Web2 tool. And at the same time, the blockchain kind of data is completely isolated in the indexing layer. So you can actually hire just normal backend devs and front-end devs, and they can communicate by specifying the data format and the data schema that you want to show on your mobile or application, for example, for a data marketplace, and you also can communicate with the designer. And the blockchain part is really a very specific thing that you put into backend. All right. So let's unpack how exactly this indexing middleware works. So you have a blockchain node, and the blockchain node sucks up the data from the indexing middleware, ingests the data from the blockchain, and it decodes this data block by block, then transforms it into the form that can be then shown into your UI. So it's like an adapter between the blockchain and the API that your front application uses. But this is how like most applications like indexing middleware work today. And there are like several reasons why this design may work for simple applications, but I believe that it's bad for more complex ones. The reason is that it just doesn't scale once you're expecting that the TPS are going to increase. Because you're taking data directly from the blockchain, and there is no way that you can discern this data, like the useful data from the one that you're not interested in. For example, if you're building a smart contract on Aster, Aster blocks contain information about all the applications and all the smart contracts. But you're really interested only in the contract that you have deployed, because this is your dApp. Even in the situation where you actually have a dApp chain, if you expect that your application is a high throughput thing, you still need to ingest everything and decode this from the blockchain, from the block. And this ingesting and decoding and then serving it as an API is where your bottleneck is going to be. So it is very, it is kind of putting everything into this place, like putting all eggs in the same basket. And this approach doesn't scale if you do not separate the data transformation and the data serving. And this is how we came up with the idea of Subsquid, basically to specialize data ingestion and storage and the data transformation layer, which then goes directly into the API. So we have a modular architecture which consists of archives. These are actually nodes that you set up only once, and they do all the heavy lifting of ingesting the data from blockchain, aggregating it, storing it, and making it available for the downstream processing. But there is no actual indexing happening here. It's basically making the blockchain data in the right format so that it can be used efficiently. And then there is a bunch of squid processors, like squids, that actually tap into the archive, and they may share the same archive, and this is where the transformation logic actually happens, and this is fully customizable, and this processor are lightweight, and thus it is very easy to scale them if the load grows for your application. So this is where we are at the moment. Subsquid already powers 70+ dApps and wallets on .sama. We have a hosted service where you have the possibility to instantly launch your API and basically run a backend for your dApp within minutes. We support pretty much all the major parachains, and if there is demand, we can pretty quickly set up support for any new one, in particular for testnets. We natively support EVM on Shiden in Aster, and also on Moonriver and on Moonbeam, which is a great feature if you, for example, want to leverage XCM and have both EVM and substrate mixed into your dApp. So let's unpack the modular architecture a bit more closer, which, as I mentioned, have two pieces, archives and the squids. And we start with archives. So basically, archives provide scalable storage and an efficient interface for raw on-chain data. So basically, the main goal of the archives is to make sure that you can serve your blockchain data at scale, no matter how large is your blockchain and how many data consumers you have. This is something that is hard to do if you ingest this data directly from the blockchain node. So once we figure out how to store terabytes of on-chain data, the archives can batch the transactions and extrinsic information across multiple blocks for the downstream processors. So if you remember the picture where there was this poor dog, then actually the main problem was that this poor dog doesn't know where to get this data, on which particular block this data is located in. But in here, you can just ask the processor a query which looks something like this, which says give me a batch of everything related to a specific contract from, say, block 1 million to 1,100,000. And then if there is a lot of information, do pagination over it. So this batching, which is super fast compared to direct access to the blockchain node, allows all the downstream processors and transformations to pick up this data very efficiently. Another important feature that we kind of discovered that it was a surprise for ourselves because like devs started to use it, and then we realized, oh, okay, this is probably something that it is actually useful, is that archives come with a gateway, like an API, which already works as a sort of block explorer, which allows you to query your blockchain in a very flexible and efficient way, and it just works out of the box. So for example, this is a query that I just ran against the Kusama archives, and you can instantly pull out information about, say, Kusama treasury proposals and just see the raw data. As you see, like archives don't do any fancy transformation, so this is pretty much the same way that this data is stored in blockchain. But for developers, this actually has great value because this is actually what you are working on if you're developing a runtime model or like a palette, or you want to see how exactly these data are packed. So here comes the features that are not currently present in the current version of archives, but that we are going to release around the end of June at Polkadot Decoded. The first killer feature is that archives gonna support lookups of proxy and batch calls inside extrinsics, which means that, so why is it important? So before, the developers that work with runtime models were struggling with extrinsics that actually encapsulate a lot of transactions. So for example, you have a single batch calls, and this batch call contains a lot of calls inside. So if you want to get some information from one of these calls inside the batch, you actually have to listen to all these batch events. There is no way you can actually pick into this without like going through all this batch. This takes a lot of time and very inefficient. With a new archive release, you can actually call this, like fetch this data directly. And for example, in this live query, you can just pull up all the system remark calls. And if you're doing remark indexing, this is actually what you need to do in order to run an indexer and process this, because this is where remark information is stored. Before that, you would have to go through all the batch events. The next killer feature is that Subsquid archives are incredibly fast. And actually, this is the fastest block indexer on the market. It's much faster than even the Substrate archive, which is Rust native, because it's actually run on a cluster of nodes, and you can throw as many gRPC nodes into it as possible. So it's actually horizontally scalable, and as long as your database can tolerate writes, this is actually the limit. So we have observed the indexing speed over 600 blocks per second. So the call Kusama takes about like 20 hours, like all the 12 million blocks. Okay, so that was the first part. The second part is to unpack the squids, where the actual data transformation happens. So the squids pull data from the archive and transform the data from the archives into human-friendly GraphQL API. It all starts with actually defining the shape of your data. You do the data modeling through a special schema file. So for example, this is actually an excerpt from like Codadot, like a live example, where you define which data you want to show to your users. So in this particular example, you have collections, unique collector, some statistics, and this is what you pull through API here. Once you do the data modeling, you have a fully functioning GraphQL API straight out of the box. You don't need to do anything else on top of it. And in fact, in order to like run the data ingestion process, you have a lot of information available already while you type your code in VS Code, because everything is configured through the code. So for example, if you want to add explanation on like how to add data processing, you just like pull out auto completion, and you have all the documentation already available in VS Code. The next killer feature is the native support for runtime upgrades. This is something that is very important once you develop a Substrate application on your own chain or like your own palette. Basically, this runtime support works through like extensive tooling and generation. So we are very proud, and we have probably the best tooling around it in the space. And we have similar tooling for EVM contracts that actually generates all the necessary typings for your contracts, and it makes the indexing a lot less error-prone and very easy. And finally, you can actually enrich your data that you pull from the chain with any external APIs, like, for example, CoinGecko or like any other service that you can use directly from the code which do the mappings, the data transformations. And if it's not enough, you can actually do like custom extensions. This is like an example, again, pulling live from the coded example. So they have a very complex query that they actually run in order to show statistics on how the remark NFTs were used, like who was collecting them, what was the average price, and so on. So you just pull like a very complicated SQL query, and you can just show the results with a custom GraphQL endpoint. This is how usually it looks like. So this is a live query, which is just automatically generated out from the code that you defined. So and here comes the announcement of like what we are going to have in Subsquid. As I said, there will be magic related to batch calls, so you don't have to manually work on it. You will be able to use secrets as environment variables. This is very important if you, for example, want to use some private API in your data transformation logic. So, for example, like pull some API where you have API key. And we are going to support WASM contracts on Aster. This is also very important as the ecosystem is like really brewing and growing. And last but not least is that there are going to be subscriptions via live queries. So basically you will be able to set up a GraphQL query, and as long as the results changes, you will have a WebSocket notification out of it. So when? Well, that's going to be at the end of June if everything goes live. Everything is already in tests right now. We hope it will be ready. But there is one thing that I want to mention to you, is that everything right now requires like a development experience, like some dev knowledge in order to run. But what if I told you that actually there is a single GraphQL endpoint that you can use already today? So it actually collects all the assets, NFTs, XCM transfers, crowd loans, staking rewards, and everything pulled together across all major parachains, and it's still like a single endpoint. This is actually like a Subsquid, like a single squid to rule them all. And this is actually how it looks like. You have a bunch of endpoints for Akala, Aster, HydroDX, Polkadot, Kusama, and for each parachain, you have lots of data compiled into you. And for you as a developers, it boils down just to specify which data from each chain you want to pull, and you actually compile it from multiple chains. And this is the power of GraphQL in action. And you can pull it in a single query and get all the results. And The thing is that we can actually pull more and more data and then more parachains without sacrificing scalability, because this actually comes from stitching multiple squids. So this is like a really growing squid that rules them all. If you're interested and want to try, I really suggest you to navigate this link that hosts 3 bounties that we do for Polkadot North America. There are links to documentation and to Super API that I just mentioned. It is still in beta and is still being developed, but this is like a very good glimpse of what we are going to release around Polkadot Decoded. And of course, feel free to ping me on Telegram and follow me on Twitter. Thank you very much for your attention. Questions?
Thanks for the presentation. So is this API or actually the service, is it decentralized or is it centralized?
Currently, it is run by our services. Yeah. So it is centralized. The code is open sourced, so actually anyone can run such a service. And the platform is open source as well. So.
And who is indexing subgraph, parachains, and other stuff? Are you relying on third-party indexers or your own indexing nodes?
Sorry, I didn't get the question.
Who's indexing blockchains? Who's indexing data?
Ah, okay.
Graph protocol using third-party indexers, curators, and
Yeah, that's a great question. So right now the service is decentralized, so it is used as a software as a service, and it is free to use. And we are actually developing decentralization around it, so there will be multiple rails for running archives nodes, for running indexers, and so on. But this is probably like 1 year away from now, something like this.
Thank you for your presentation. My simple question is, why is it called Fire Squid?
Because fire squid is very fast.
Okay. Then one. One more question then. Do you have indexer for Calamari network?
Yeah, actually we do. And we actually had an integration with them, I believe. Yeah, squid being squid. All right.
All right. Thank you, Dima, for the talk.